Pandas, the most powerful data frame processing package, is the concept for present session. So before starting to work with Pandas, make it sure that or ensure that you all have installed the Jupyter Notebook on your system. If not, you are familiar with the Google Colab, provided you have a complete internet support. If you are familiar with any other platform or IDE to work on the machine learning algorithm, that's also preferable. We don't have any issue, right? So moving on to understand what Pandas is and why is it becoming the most popular, powerful package. So let us understand what a data frame refers to. The data frame could be mapped just to a two-dimensional array, according to me. So any data set, as we have discussed earlier, finally ends up in the format of a two-dimensional matrix. So the number of dimensions may be many, but you can bring it down to a two-dimensional matrix to make it workable very easily. And just map this two-dimensional structure to a relational database. I hope you all can agree that. So what happens in collecting the data set? These columns are, so let me refer the attributes with the name A, B and C, and the rows will correspond to. So this is what is the attributes of the corresponding data set, and the rows correspond to the experience that we are collecting from the entities, right? So entity 1, entity 2 and entity 3. The similar structure is there in a relational database where we call the attributes what we refer to here as in the which are stored in the columns to be the columns over there, okay, and for every row we'll be trying to keep on adding, which will refer to a particular tuple. We say there it is a tuple. Okay, so this is the prerequisite for this session. You should have installed Jupyter or else ready with Google Colab, and you should have sufficient understanding on the NumPy package. Okay, so having done that, we can move on for Pandas. So now, so having defined this data frame, you just assume it to be a two-dimensional array. That's much more easier. So now there are different ways to create a data frame. Okay, so the most important thing is, if you want to create a data set of your own, you can create a data frame from it using this structure. So why we have specifically represented this as a dictionary is that dictionaries specially have a format of key and the columns. The key always has to be a unique entity, wherein the values, if you represent the corresponding to a key, can have multiple values, okay, put together. So in a corresponding data frame, the similar structure is required, wherein the entity has to have a name which you can map to a key, and all the values corresponding to an entity can be mapped up to a values corresponding to the key of a dictionary. Okay, that's why. So this Pandas is a package. So as we know well, any method can be accessible by using this dot operator, pandas.data frame of within bracket you should give the dictionary name. So if you give automatically, dictionary is the name of the dictionary you are going to pass, which should have values in the format of key values pair, right? So the keys will be taken as your row attributes, row entities, and your values will be taken as your attributes. So that's what it will do for you. And I hope capital D and capital F should come over here. Okay. And okay. So now, how to, next is one special kind wherein if you want to represent, okay, columns represent your feature set which will be represented by an attribute name, right? So, but what if I want to index every entity? Let's say the first row corresponds to entity A, second row corresponds to entity B, so third row corresponds to entity C. How to represent that is by using this format. Index is equal to, you can create as many number of experiences or rows. Okay, so that's where. And it is not enough always to create a data set of our own. Most of the time we have the data already stored in a CSV format, which is being collected from different sources, either a comma separated file or an Excel file. You should have the provision to read it, right? So the provision is available. So pandas dot, if you want to read a CSV file, it is read CSV. An Excel file, it is read. Okay, so the path of the file where it is stored onto your computer has to be given. So finally, it will return a data frame for you. This is an user defined variable which you can define of your own. Okay. So now that we have to understand from where and all the data frames can be created. Okay. So our own random data, that's what we have seen. We'll see shortly with the example also to make it more clear. So you can make it from CSV, XLS and XLXS, both for Excel file. And nowadays, the practice of using JSON data is most commonly useful now. So that JSON data also you can, because if you look at the structure of a JSON data, you can very well map it to a dictionary, right? So and hence this JSON data can be converted into a data frame. And as we have discussed about the relation between this relational database and this, whatever data you already have stored in a SQLite. SQLite is a package supported in Python in order to have a relational database structure. It's similar to your Excel or Access or Oracle. So if you have any table stored over there, you can create. Okay. So that's where the sources of data frames are. Okay. And so it's not only enough to import a data to a data frame. That should be after processing the data frames. What do you mean by processing? You may want to replace some value, you may want to do some calculation, you may want to add some value, and so many different operations you may want to perform. And after performing all those things, you have to have the provision to store it back to similar format. So it provides CSV, Excel, SQLite and JSON data, right? So coming to the operations now you can do with this. I am listing very few that will be normally in use in machine learning algorithm. Info to state to give the complete description of the data, and you have shape which will tell how many number of rows and columns are there. That represents the number of entities along with the number of attributes. And mostly the size of the data will go long, ranging from hundreds, thousands, lakhs and so on. So at one stretch it's not possible to view. So we have two provisions, head and tail. Head will give you the first n number of records. Tail will give you the last n number of records. This is most often used to find out whether the data has been loaded properly onto the system or not, or if we do some lambda operations, whether it was done or not. So in both the cases, if you are not representing how many rows you want, it will, by default it will be 5. So otherwise within the bracket you have to state how many number of rows you want to get displayed. Okay. And the most common thing, so you can drop duplicates. Okay. So this drop duplicates will remove the duplicates on the row. Okay, so on the row in the sense, if similar columns is there existing across the column, see, most of the time if you collect data from people, okay, they may end up with duplicate values, you can remove it. What is this in place operator is like? Suppose if I have a data frame named df, okay, so like how we normally use I, j and k, so now we also use df, that's it. You can have any variable name, sorry. So df is equal to, suppose I want the duplicates to be removed from this data framework and I want to get it replaced there itself. So what to do? You have to give in place is equal to true, which meaning that the operation has to be performed on the data frame and it has to be stored back in the data frame itself. Okay. So there is one more optional parameter which is keep. So it means that whether you want to keep any data after finding out the duplicates. Let's say if there are 3 duplicate rows, common rows for a particular entity. So if you write keep is equal to first, it will retain the first row, removing the next 2 rows. Similar to that, if you write last, it will keep the last row, removing the rest of the rows. If you write false, then automatically all the rows will be deleted. So what happens, this keep, if you keep it to false, set it to false. So it will remove if the entity has a duplicate data, that's it. Okay. So and the commonly used methods, you have columns to print the attributes of the data set, and you have a rename. Suppose while importing, if you feel like the length is more and if you want to rename, you can do. All set of comprehensions can be used. Let's say the entire value can be sum up with an extra value of 5. So that's possible. You can check whether null values are present in the data set. This is more useful. And if you want to drop the rows or the columns, whichever is having null values, you can use drop NA. Okay. So the axis with which, let's say, if a row is having null value, if you want to drop out the rows, you have to set axis equal to 0. Axis equal to 0 represents x axis. Axis equal to 1 represents y axis. That's the normal configuration. So when a column is having null values, if you want to drop it, then you can use drop NA, comma, axis equal to 1. Okay. Now, commonly, so in continuation to that, we have described stating the complete statistical information about the data set. It will tell you what is the mean of a column, what is the variance, what is the standard deviation. If you consider first 25% of the data set, how much is the standard deviation and other stuff, all those things will be given by this describe command. It helps us to understand the statistical variation among your attributes. And you have mean to find out the mean of a column, count how many number of entities are there on a column, and you have median, mean, median, mode are all important statistical concepts. The standard deviation, variation and variance can also be found, and similarly you can find minimal and maximum value among the attributes. Okay. And if you want to concatenate two data frames, that is also possible. So just you have to use concat command. So df dot concat of df1. So the content of df1 will be appended to the df. Okay. So ignore index equal to true if you give, then without considering whatever be the index of df and df1, both will get appended. Otherwise it will check for the index mapping also. Okay. And since we already have seen a mapping between the relational database structure along with the Pandas data frame, all the activities should be supported, right? Basic operation. So you can create a table over here as we have seen. You can add up the contents. You can perform select operations. You can list out only a particular attribute value and basic operation. Similarly, this group by is a very important operation that is normally performed in your relational database based on a particular column value. Let's say if you are going to store a database or a value for the employees of an organization, based on the department you may want to do some operation. So this group by is an operation, command that is used for grouping up the set of entities based on a particular value. Okay, so we will see in the example of how it works. And correlation, this is again most powerful tool meant for feature reduction. So you can identify how much a particular attribute is correlated towards another attribute. So there is a very simple command that can perform this operation for you. Okay, and as usual we may want to have slicing. Okay, without slicing it's not at all useful for us. So that slicing can be done in two ways. One is LOC, another one is ILOC. This is not leave out this command. This is not okay. You have to assume it will be ILOC, not LLOC. So it is ILOC. So LOC you have to give by name. Let's say df.loc of serial number. It will display all the values in named serial number. Okay, so this ILOC means indexed location. So it will access by index. You know, while getting stored on the computer, it will be indexed from 0 and it moves on. Okay, so you can access it by using this index. Otherwise, the slicing concept is same. Okay, in all the things we have an enough introduction about slicing in our previous lectures. You can have a look at it. So inside the square bracket, you have to give what is the value of rows and what is the value of column. Okay, again you can have multiple values given here. If you want to have a range, you can have colon. So if I represent 1 colon 3, it means, so it will include rows starting from 1 ending till 2. That's it. Similar to that. Before concluding the session, we'll have a look at the IPython notebook that I have created. So as usual, I'll be making it available on the portal. You can download and you can make use of it. Okay, and note that in certain parts of this file, okay, I have given the text called try yourself. Okay, and I have left the blank block next to that. and I have written what you need to do as part of it. Okay, I expect all the readers to work on it, and if at all there is a doubt, first of all you can start a discussion forum and you can come for a discussion. Shortly I'll be creating a discussion forum for all the users in a different platform and load it over here. Okay, to start with, so this IPython notebook. So initially I have imported the pandas and I have created an object called PD. So this is an example to you create a data set frame of your own using a dictionary. So for the dictionary, this what I have did is I have created a dictionary for 4 students having 3 subjects mark. You can see it was converted into a data frame. Okay, you see this index gets created automatically. If you don't want this index, if you want to make this ID to act as an index, that you can do. You can see the comments below. Okay, then this is not, it's not enough to create a data frame of our own. How to open up, import a CSV file, pd.read_csv of. So I have downloaded a data set got character deaths. Okay, from in the next session I'll be discussing in detail about the data sources. So I'll attach this data set also with this lecture so you can make use of it. Then I have used head command, and you can see the tail is being used. Then I'm storing it back to a file, and if you look at here, the result file has been created out of that execution, and I have given an exercise for you in between, simple operations that you need to include to make yourself comfortable. Okay, then you can see here their normal index, it will be indexed with 0 to n. Now I want to make the gender as the index, that you can do. Okay, so this is the command that is for that. So gender is a attribute over here that I want to make it as an index, so that is possible. You can check it out by removing the comment line, and all the operations I am showing, so you can work. So, and the shape drop duplicates we have seen, and I have given again an exercise to for you to practice. Then I am printing the columns, and I have renamed some of the columns, and I have used to describe. You can see it displays how many number of values are there in every column with mean, standard deviation, the minimal value, maximal value, and what is the deviation in 25% of data, 50% and 75%. Similarly, using some of the operators, I have listed out some of the operations using count, unique values, all those things, and about ILOC and LOC, how to access. Okay, so using ILOC, I have given both the description as well as the example for you. While we want to create a subset of whatever data is available based on some of the conditions, right? So what I did is, DF2 is the data frame that contains the data, got character death data. So there is one attribute called death year. So I have given the condition, if the death year is less than 400, I am creating a new data frame. So whenever this attribute's value is less than 400, only those entities, the tuples will be added to this data frame. Okay. So again, how to create a subset of that. So it will have only an index stored over there. So what to do? Again, df2 of df3. This df3 is the resultant index that is being created. So this df4 will give you this thing. Okay, you can print both the df2 as well as df3 and check what's happening. And this group by, it's self-explanatory. df2.groupby of death year. So the characters when it got dead is given over there. So based on that, I am finding how many characters have got dead on a particular year. Okay, and similarly, it depends on our own thought process of how these comments are readily available. What you think of it completely depends on our own thought process of how we are going to use it whenever data is required. Okay. So coming to visualization, there are different packages, special packages available, which we'll be shortly looking at in the next session. But this data frame supports basic plotting line plotting, scatter plot. And this kind of plotting can be given like this. Kind is equal to what is the plotting you want. Line plot is line plot, which is default. You can have bar graph, histogram, box plot, pie chart, and a scatter chart. I have drawn a scatter chart for you, displaying, so in x-axis there, death year in your x-axis and y in your gender in your y-axis. Okay, so that's, and I have given a small exercise to test your understanding. Okay, and there are questions. I hope all of you will work on it, and if there is a doubt on it, you can always write to me. Okay. Hope now you can import pandas and perform the operations. You can open up a data set, perform operation, store it back to your system, and you hope you can visualize your results using pandas in a little way, right? Thank you. So once this NumPy and pandas is done, we can move on to work with the specialized visualization package called a PyPlot. Thank you.